Hi everybody, I am taking you to the interesting topic of an operating system, the most fundamental concepts of operating systems and the most important and most interesting topic, that is processor scheduling. In this, I am not going to talk much about the algorithm to achieve the scheduling concepts, but in this entire presentation I am going to give you the brief glimpse of what do you mean by scheduling, why we want to go for a scheduling. All these things we are going to discuss in this presentation. Now let me go back in I turned a few pages back of my own books to understand what do you mean by a processor and what do you mean by a process. A processor is a hardware component which facilitates the system to execute certain operations to achieve a common goal. So typically a processor is, we can say, it is a group of microprocessors to perform a certain operations to achieve the common goal. Now what do you mean by process? Now processor, as I said, we want to achieve certain task. Now the task is in operating systematically way, we can say that is called as a process. A process is called as a program in execution. A set of instructions are clubbed together. It makes uses of a processor to get the result. Now process is a program in execution. It is a set of instructions. Okay, right. Now as per the operating system's point of view, that is as per the system's perspective, the operating system, that is a program in execution, it comprises of both a processor cycle and that is a CPU cycle as well as also the IO cycle. That is, it is a combination of IO cycle and as well as also the CPU cycle. That is, in sometimes it may spend the time to execute some instructions, and sometimes a program may spend the time to get the input and outputs. That is why it is a combination of any program execution, it is a combination of both the CPU cycle and as well as also the processor cycle. That is a CPU cycle and as well as also a IO cycle. That is, we can say the CPU burst and as well as also the IO burst. So said a process is a set of program in execution as we know that a process it have its own states. We can states that those states are 5 states. One is called as a newborn state, that is a new process is generated, and second, whether the process is ready to execute or not, with all the IO requests are satisfied, all the resources are allocated, that is it is there in the ready queue. And the next one is running state, the process is actually executing its own instructions with the help of the processor. and still if there is any IO is needed, so it will move into the waiting state. It will wait for the certain period of a time to get those IO devices or the resources to continue its own operations. So now that process is migrated, that is shifted from a ready running queue into the waiting state. And from the waiting state, if all the processes if all the resources requested by the process to continue for its own execution is allocated, then it will be moved into the ready state, or otherwise it will wait for the certain moment of time, and still if the request is not at all satisfied, the waiting time is keep on still increases, then process is voluntarily kill itself, then that it goes to the exit state or a terminate state. So in that condition the process is voluntarily kill itself, and this is called as an abnormal termination. And once all the resources are allocated, who are the processes are resided in the waiting state, if the requested resources are allocated by the controller, then it will be moved into the ready state, then from the ready state into the running state, then automatically the process is going to execute its own instructions and complete its operations, then it is moved into the terminate state or exit state. Now this we can say this is called as a normal termination. So if there is any other possibilities, like when a process is switched from the running state into the waiting state, if there is any other possibilities are there, it means that it is not only for IO requirements on any resources. If there is any other thing is there, when a process is encountered those things, then it is automatically migrated from a running state into the waiting state. That another one beautiful factor which is called as a priority. That is, whenever a higher priority process is getting into the processor for its execution, automatically the lower priority process will be swapped out from the processor, and it will be stored into the waiting state. This is a way we can define the process states. So there are totally 5 processing states, as I said earlier. One is a newborn state, second one is a running state, a ready state, and third one is running state, and fourth one is waiting state, and fifth one is either the terminate or exit state. Okay. From my conversation, it is easy to understand that it is migrated from a running state into the waiting state, or the waiting state into the ready state, and ready state into the running state. Now in this context, we knew that we have a queue is available in each and every state to if any process is moving from the ready state into the running state, then how we will come to know that which process we want to migrate from a ready state into the running state. Now we have a queue which is available in the ready state. Now in that queue, the next process whichever there in the queue, it follows the mechanism of a first order. So we have to take the process and put it into move it into the running state. Okay. Now this concept is called as a dispatcher. So a dispatcher, it will take a process from the queue, that is especially from the ready queue, then it will put it into the running state for its execution. Now this concept, now which process we want to allocate into the running state, that can be done with the help of the operating systems, that concept is called as scheduling. So we have to operating system have to give the scheduling decisions, so that any process whenever in a running state, it will be migrated from the running state into the waiting state, and if there is any ready queue process, then it will be moved into the running state. Okay, so the scheduling is a major concept which will which facilitate the operating systems to optimize or use the processor in an effective way. So the scheduling gives the optimal way to utilize the processor of all the processes. Okay, now we can say the scheduling is, there are in general way the scheduling is, there are non-preemptive scheduling and preemptive scheduling. There are two types of general scheduling algorithm. One is called as a preemptive scheduling, and as well as also the non-preemptive scheduling. What I mean by preemptive scheduling? A preemptive scheduling is, if any process is holding some resources, if assume that if any higher priority processes is requesting those resources, and the requested resources is voluntarily is taken out from the processor, and which is lower priority process, and which is allocated into the higher priority process. Now this is called as a preemptive scheduling, that is voluntarily all the process are releasing its resources before completion of its execution. Whereas a non-preemptive processing, now there is no volunteer mechanism like that. After successful completion of its execution, every process is going to release its resource, the allocated resources. Okay, now in this entire presentation we are going to talk about the types of processor scheduling, the scheduling algorithms, and traditional Unix scheduling. As the types of processor scheduling, it can be divided into the three way. One is long term scheduling, medium term scheduling, and high term scheduling. The scheduling algorithms, as I told earlier, in general way we can say it is called as a preemptive scheduling and non-preemptive scheduling, and under this we have a four major category. One which is called as first in first out scheduling, second one shortest job first algorithm scheduling, and third one is called as a priority scheduling, and the final one which is called as a round robin scheduling algorithms. The other way we can say the processor schedulings are, there are multi-level scheduling and multi-level feedback scheduling. Now in our Unix, the traditional Unix operating systems, it follows the concepts of a multi-level feedback queue along with a round robin scheduling algorithms to achieve the concepts of processor scheduling, especially in the Unix operating systems. I hope you that this presentation will give you given you a prompt informations about when and why we need to go for a scheduling for the from the operating system's point of view. Thank you.